employees in many different industries work with hazardous chemicals. The Occupational Safety and Health Administration, or OSHA, has an occupational chemical database currently listing more than 800 hazardous chemicals used in U.S. workplaces. Many of these chemicals can cause injury or death if workers don't take the right precautions. It's important to understand the chemical hazards in your workplace, how to obtain information on those chemicals, and what to do if a spill or accident occurs. Once you've completed this course, you should be able to recognize the purpose and requirements of a hazard communication, or HAZCOM program, and identify chemical hazards and their controls in your workplace. You should also be able to identify sources of information for workplace chemical hazards and requirements for medical record keeping. Lesson 1. HAZCOM programs and their requirements. Chemical exposure can lead to a variety of illnesses and injuries, ranging from burns and rashes to nervous system damage, organ damage, and cancer. Some chemicals can produce flammable or explosive vapors that are colorless and odorless, meaning that you might not know they're there until it's too late. Some chemicals also produce toxic vapors that can be colorless and odorless. Exposed workers can experience both immediate and delayed health reactions to chemical exposure. Some chemical reactions might not be noticeable for months or even years after exposure. Finally, some chemicals can react violently with other chemicals, creating additional hazards and making existing hazards even more dangerous. To help protect you and your coworkers, OSHA requires your employer to develop a hazard communication, or HAZCOM plan, that addresses the chemical hazards in your workplace. HAZCOM plans don't prevent you from being exposed to hazardous chemicals. However, they can give you and your coworkers knowledge, training, and equipment to help you work safely around the chemicals in your workplace. As part of your facility's HAZCOM plan, your employer must list all the chemicals that your workplace uses and the proper protective measures for them. A HAZCOM plan must also include the chemical's label and warning information, each chemical's training requirements, and where you can find the safety data sheets, or SDSs, for each chemical in your workplace. It's important that you follow all the safety precautions in your facility's HAZCOM plan. It is your employer's responsibility to develop and enforce a written HAZCOM plan and provide you with all necessary training. But it's up to you to follow that plan and training while you're working. You are responsible for wearing any necessary personal protective equipment, or PPE, and inspecting it before each use. You'll also need to be familiar with all chemical hazards in your workplace. Know your facility's emergency procedures. Report injuries or spills immediately, and ask questions if you're not clear about a chemical's hazards, a safety procedure you're responsible for, or any of your job duties. Make sure that you know exactly which chemicals you're working with or around and how to protect yourself before you use them. Lesson 2. Workplace chemical hazards and controls. Chemicals in the workplace can create several hazards. Toxic chemicals can enter the human body through several routes of entry, causing damage at the first point of contact, as well as throughout the body. Flammable vapors can produce intense heat and open flames, while also releasing smoke and toxic gases. Corrosive and reactive chemicals have the potential to release toxic gases and vapors, as well as degrade equipment and machinery. While many of these hazards are dangerous enough on their own, different chemical hazards can exist at the same time and make a situation even more dangerous. For example, a drum containing a corrosive chemical could leak and cause a spill that contacts a reactive substance. That reaction can release a flammable gas, and a spark could cause a fire or explosion. The most common type of chemical exposure is inhalation. This happens when a chemical's vapors or fumes are breathed in, allowing the chemical to pass into the bloodstream through the lungs. The second most common route of entry is absorption. Absorption happens when a chemical comes in direct contact with the skin or mucous membranes. This can cause a reaction at the point of contact, such as a chemical burn or rash, but it can also allow the chemicals to pass through the skin or mucous membranes and enter the bloodstream. Mucous membranes are the especially fragile tissues that line the eyes, nostrils, lips, and other areas of the body. Some powerful chemicals can be absorbed directly through healthy skin, but many more chemicals can be absorbed through mucous membranes. Many chemicals can also be easily absorbed through broken or damaged skin, such as cuts, scrapes, or sores. Another route of entry for hazardous chemicals is ingestion. Ingestion occurs when someone accidentally eats or drinks a chemical. It's rare for a worker to ingest chemicals directly. What's more common is eating or drinking contaminated food or beverage. For example, if you have a chemical on your hands and don't wash them before eating, you could ingest trace amounts of that chemical and get sick. Always wash your hands after handling any chemical, and never handle food or drink while wearing potentially contaminated clothing, or PPE. The last route of entry is injection, which is when a chemical bypasses the skin and enters the bloodstream directly. The most obvious example of this is intentionally injecting a drug with a hypodermic needle. But accidental injection can also occur if a person cuts themselves on a contaminated sharp object, such as broken glass or jagged metal. To protect yourself and your coworkers from workplace hazards, your employer is required to implement hazard controls. Hazard controls are measures designed to eliminate or minimize hazards. When it comes to chemicals, the most effective control is to either eliminate the need for the chemical or substitute it for something less hazardous. If hazards can't be eliminated or substituted, the next most effective control is engineering controls. Engineering controls shield or separate workers from a hazard by changing the work area. Examples are keeping chemicals in a piping system or ventilating the workspace to keep workers from contacting the chemical or its vapors. If engineering controls don't eliminate or sufficiently reduce a hazard, administrative controls or safe work practices and policies should be implemented. Designated storage locations and policies for chemical handling are types of administrative controls. If hazards still aren't sufficiently controlled, personal protective equipment, or PPE, such as gloves, goggles, or face shields are used. PPE can't remove your work area's hazards or make them less dangerous. It simply provides a barrier between you and the hazard. It is only used after the other controls have been implemented. Lesson 3. Sources of information for workplace chemical hazards. OSHA uses the Globally Harmonized System, or GHS, to classify and label chemicals. GHS labels display one or more of 9 pictograms to help workers identify that chemical's hazards. Labels must also show a signal word, either danger or warning, that indicates the relative severity of the hazard. Danger indicates a more immediate or extreme hazard than warning does. GHS labels must also have a hazard statement, which describes the nature of the chemical, and a precautionary statement, which describes the recommended precautions to minimize the effects of exposure to that chemical. The label must also have a product identifier, which tells the chemical identity of the substance. Finally, GHS labels must list the supplier's information, including its name, address, and telephone number. Make sure that you can read and understand the GHS label before using or working near any chemical. Each GHS pictogram is a black image on a white background, surrounded by a red diamond. A health hazard is represented by a person with a star symbol on the chest. This pictogram indicates a long-term or chronic hazard, such as a carcinogen, mutagen, or chemical that makes it difficult to breathe. A flame symbol represents flammable chemicals. An exclamation mark represents an irritant, skin sensitizer, or chemical with narcotic effects. A gas cylinder stands for gases under pressure. A vial being poured onto a hand and metal bar indicates a corrosive material. An exploding bomb stands for an explosive material or organic peroxide. A flame over the letter O represents oxidizers. A picture of a skull and crossbones represents acute or short-term toxicity. The last pictogram, showing a decaying tree and fish, represents environmental toxicity. OSHA is not directly responsible for environmental protection, but you're still likely to see this pictogram on some SDSs and chemical labels. For more detailed information about the hazards of any chemical, you can consult its Safety Data Sheet, or SDS. SDSs contain information about chemical hazards, handling, storage, and disposal information. SDSs will also contain exposure limits, such as threshold limit values, permissible exposure limits, and any other exposure limits recommended by the chemical manufacturer or importer. SDSs should be reviewed by each person that handles, stores, or disposes of the chemical. Keep in mind that one SDS may apply to multiple complex mixtures having similar contents and hazards. An SDS must be available for each hazardous chemical in your workplace, and those SDSs must be kept in a location where you and your coworkers can access them as needed. If an SDS is lost or didn't arrive at your facility with the chemical, your employer will need to obtain additional copies by contacting the manufacturer, importer, or supplier of the chemical. Safety data sheets are formatted with 16 sections. The first section is identification. This includes the product identifier, manufacturer or distributor name, address, contact, and emergency phone numbers, recommended use, and restrictions on use. The remaining sections are hazard identification, composition and information on ingredients, first aid measures, firefighting measures, accidental release measures, handling and storage, exposure controls and PPE, physical and chemical properties, stability and reactivity, toxicological information, ecological information, disposal considerations, transport information, regulatory information, and other information. SDSs are the best place to find detailed, accurate information about the chemicals you will be working with and around. Always consult the SDS before working with a new chemical and periodically consult it when working with familiar chemicals. If you'd like more information about SDS sections, click on the link on your screen. Each chemical's SDS contains one or more hazard ratings, which are numbers or letters that indicate the type or severity of the hazard. For example, flammable liquids are categorized from 1 to 4, with 1 being the most flammable and 4 the least flammable. Self-reactives and organic peroxides are categorized by type, A through G, with A being the least stable and G being the most stable. Acute toxicity is categorized from 1 to 5, with 1 being most acutely toxic and 5 being relatively low acute toxicity. The hazard category does not appear on the label. You can only find it by consulting the SDS. The label will show the correct pictogram, signal words, and other hazard information appropriate to the chemical's hazard category or type. While the Globally Harmonized System, or GHS, is the most common hazard information and labeling system you're likely to see in your workplace, you may also see other systems that don't align with the GHS system. These may include National Fire Protection Association or Department of Transportation labels and placards. You'll need additional training on whatever systems are present in your workplace. But if you'd like information on some of these systems, click one of the links on your screen. Lesson 4. Medical Record-Keeping Requirements. If a chemical incident occurs at work that requires you to be evaluated for chemical exposure or requires you to receive medical treatment, your employer is required to keep a record of your evaluations and treatments. You have the right to access these records. These records can include medical questionnaires or histories, medical exam results, medical opinions, first aid records, treatment descriptions, or medical complaints. These records do not include physical specimens, such as blood or urine, most records concerning health insurance claims, records created solely in preparation for litigation, or records concerning voluntary programs, such as alcohol, drug, or other counseling programs. You have the right to examine and copy medical and exposure records and any analysis based on those records. In certain circumstances, an authorized representative can access your records as well. These records must be provided to you free of charge and within a reasonable amount of time, which is typically within 15 days. Medical and exposure records are confidential and must only be released to you or your designated representative. There are 3 ways you can access your records. First, your employer can provide you with a copy. Second, your employer may give you access to facilities where you can copy the documents yourself. Third, your employer can loan you the documents to copy somewhere else. In some situations, a chemical may qualify as a trade secret. This means the employer can withhold certain specific details about the chemical, but must still provide you, your medical provider, or your authorized representative with information about toxicity and other properties. Now that you have completed this course, you should be able to recognize the purpose and requirements of a HAZCOM program and identify chemical hazards and their controls in your workplace. You should also be able to identify sources of information for workplace chemical hazards and requirements for medical record keeping.